natural gas and associated gas, they are, they both can contribute to the country wealth. Again, natural gas and associated gas, they are both more or less having the same environmental and I would say contaminants. We call them contaminants, then we call them impurities, then we started calling them commodities after that. So the similarities are way more than the differences. Okay. So that's why we say, okay, you know what? We have a great experience handling natural gas. Can we apply this experience to handle associated gas? That's the idea. The idea is we do have lots of technologies available here. Why not to utilize them there? And it's been done since the early 80s that whatever we are going with in natural gas, we just copy and paste it in associated gas.
Right. Okay, so where my challenge is that you sought to differentiate associated gas from non-associated gas. You refer to non-associated gas as natural gas and the associated gas as associated gas. But I feel both are natural gas.
Yes.
For instance, if I take the case of
Samuel, you know, when we look at the reserves, we evaluate them according to the source.
Yeah.
Okay, so the definition of associated gas, it is basically an English terminology associated with what?
With oil and water.
If you want to be accurate, you have to say oil associated gas.
Okay.
Okay. Yeah. And non-associated gas means it's alone without oil.
Exactly.
That's it. It's just the terminology, but when it comes to the application, it's the same. I understand that sometimes the oil-associated gas has oil droplets in it, while the other one does not have this challenge.
Right. Yeah.
Okay. So that's all. You know.
Okay. Thank you
for the question.
Solved.
Okay. Thank you so much, Essam. And I just wanted to also reflect on, you know, when we were talking about best available technologies, and Essam, and we were discussing, you know, some of the key principles to keep in mind to be able to define what are best available technologies. And Essam pointed out that, you know, what is best available technology in one country may not be what appropriate for another country. And there are a number of considerations or conditions to keep in mind. So I just wanted to, the group to just let's have a sharing just to refresh our memory on that, so that to ensure that we understand that a bit more. So can somebody come on camera or on audio to tell us, like, what are some of these conditions or principles to keep in mind to be able to say whether what is being proposed by the operator is best available technology? We'll put that next time in our pop quiz. But so
it was there on the sticky note. It was like a big one, if everybody can remember it.
Great.
I can say, speaking Mahmoud, I can say best technology is the one who can have when you need it in terms of safety and against environmental impacts. Like, for example, what happened when it happened a GOM or the BB disaster, you know, that time it was gas explosion, and you needed some safety to hinder the blow up. So maybe it's the one who have the efficiency and effective, and when you need it to save people.
So safety is definitely one condition that to be considered. Urias, you had your hand up.
Okay, hello, Urias from Liberia. Even though we are not a gas oil producing country, but in my opinion, most as authority, if you have an operator proposing a particular technology, it will probably not be the suited technology. So what you do as an operator is to conduct due diligence and see where you can categorize that particular technology of that operator. However, you have to accept what is best in terms of all of the effectiveness in terms of, because I'm sure, for example, you have the API, the American Petroleum Institute, which says stand up for different things. So you will have to consider to look at what is internationally accepted and see whether the operator criteria actually fall within the API standard. So most of you use that as a standard reference to always regulate some of your activity. So that would be my own.
Thank you. Thank you, Urias. From my side, you were choppy, but I think what I got from your input is taking into account also the local standards, the government standards in the area, local conditions and the local standards. And then
yes,
people.
Yes, what I was saying is that we make reference to best standard as is widely accepted in the industry. For example, the API standard, for example, API, the American Petroleum Institute, we have standard for different technologies. So most often most companies will turn to want to accept what is internationally accepted. So you often don't see the operator which may be operating in your country standard as a face value, but instead see what is university and see if that can be considered too as well. Thank you.
Thank you. Thank you, Urias. And other considerations is the cost that is in the chat, and also the type of expertise needed, like whether you have the expertise or whether you need to upgrade the expertise. We'll be able to tell you what would be as the best available technology. Anything else? Sam, what would you add? What would you add to this discussion? What other considerations?
Three major things that we have to remember always: that every country is unique, every project is unique, and every location is unique. So when we choose the best available technique or the best available technology, we have to take into consideration those three things mainly. Now, of course, when we talk about the country, we talk about the expertise, we talk about the cost, we talk about also the importance of the project for that country. And I pointed at the fact that in general, energy projects are part of the national security. But the major thing that we have to take into consideration is the environmental impact. Thank you.
Thank you. Thanks, SM. It's just to keep in mind this discussion that we had yesterday. Okay. All right. So now I think I will hand back over to Bernice for introducing Module 3, and we have additional guest expert speakers for today. Go ahead, Bernice. Thanks.
Thank you, Marisol. Thank you very much. So today we are going to start with a guest presenter before SM comes in. My colleague Anne, please, if you are there, can you please introduce yourself?
And Gretza from the Norway.
Yeah, check.
You might be, she might be muted.
Yeah, please check your audio. We can't hear you. We still can't hear you. Maybe you can check your laptop if it's connected with it.
Yeah, you may have to connect your audio to the Zoom.
Yeah.
Where can she go on the platform itself to connect to the audio?
So where the audio sign is.
Where is that?
The audio sign before the video. So it's the
It's
first
like bottom left where the microphone's
on your left
logo is at.
Logo.
No, but that's just muting, right?
No,
there's a
when
little...
you click the side, it will pop up so that you choose.
Select a microphone. So there's a mirror, there's an arrow going up, Annegret,
Yes.
next to the microphone. And then you say select a microphone and same as system.
Okay.
There, we can hear you.
You can hear me now. Sorry for that.
Yes.
Okay.
Yeah.
That's fine.
Okay.
You can introduce yourself, please.
Yes, I'm Annegret Kolstad from the Norwegian Environment Agency. So I'm very happy to be here with you. I guess I met some of you before. I recognize some names and faces. So I'm looking forward to this third day of the webinar.
Okay, thank you very much. Please, you may share your screen to start with.
You want me to start now, or is it Esam?
Yes.
Okay, I thought I was coming after Esam. Right.
Just to shake things up a bit, we asked you to go first.
Yeah.
Yeah, ladies first.
Yeah. Is it okay? Can you see it? If I put it
Yes.
in presentation mode? Does it come through?
Not yet.
Oh, it says I'm sharing.
Yeah, you are sharing.
We see your screen, but you just have to put it in presentation mode. We see your screen.
Well, I think she did put it into presentation mode, but she may need to share another screen now.
You need to go
stop share.
Under display settings, Annegret, you have to display settings and you have to put duplicate screen. Click on duplicate screen.
Okay, let's see.
So like if
video,
you cannot on share and reshare again. Let's see if it will come.
Oh, more.
Are you on two screens?
No, I'm on one screen only.
Oh, okay. So that should be okay. Are you already on presentation mode?
Yes.
Okay.
And that too. But I can go out again and try once more.
Yeah.
I think stop sharing your screen and reshare it with selecting the full screen one. Yeah.
I can see if there are options. Should I share again?
Yes, you can share.
Yeah. Okay. I hope this is right on.
Yeah.
Perfect. Great.
Okay.
Yes.
Okay, so I just start. Yeah, very good. My presentation will be about regulations in Norway then. But I start with saying that international regulations in this sector have historically aimed at reducing VOCs, NOx, and sulfur dioxide, both for the protection of human health and vegetation. But today, regulators and industry focus on the emissions of climate gases, which are more or less invisible emissions and have therefore not been so easy to understand, neither their origin nor their significance. Many of you have taken part in webinars where the emissions of methane from the oil and gas sector have been the main topic. And although I have tried not to make methane as the focus of my presentation today, the thing is that if you regulate methane properly, these regulations will also reduce emissions of other substances. For example, if you are doing leak detection and repair for methane, you may achieve control with, for example, benzene. I was indeed delighted and inspired by Esam's presentations during this webinar. He has shared with us a very optimistic view with regard to solutions to all waste streams. And Canada is often in front in environmental thinking and new approaches. And I think there is a lot of things to take home from his talk.
Hello, Anne, please, 1 minute. Are you still on the first slide?
Yes, I am. Yes.
Okay. Okay.
So,
correct.
yeah, right. But good that you reminded me to come on. Yeah, okay. So in Norway, we have 5 large onshore gas processing plants for the processing of natural gas from the offshore gas fields. But what about the associated gas from the oil fields? Well, flaring of gas has been prohibited in Norway since 1971. And the development of oil field without a solution for the gas other than flaring has not been allowed. So, and this strict policy from the very beginning has been a driving force for development of gas infrastructure offshore. And that is a key point, that you need to have an infrastructure for taking care of associated gas, because they can be in small volumes, and that is why it is not cost effective to treat them, to use it. But the alternatives to flare the gas that we have used is to export by a smaller. That you've identified, and then help you. Yes, export by pipeline to connect to larger gas pipelines, or if they cannot be connected directly to gas processing plants onshore. The associated gas can be used as an energy source, like combustions in gas turbines at the site, or they can be the gas can be re-injected into the reservoir, permanent or temporary. So that has been the solutions to associated gas. Yeah, the flaring history in Norway, as I said, it has been prohibited, but flaring is still necessary for emergency and some maintenance operations. Actually, the petroleum authorities issues yearly permits for a certain amount of gas to be flared for such purposes. And we have had the CO2 tax from 1991, and later also the ETS quota system, which provide incentives to further reduce flaring. So although flaring is now limited to shutdowns, startups, and pressure relief for maintenance and process disturbances, there is still a potential for further reductions. Besides flaring, venting and fugitive emissions are widely recognized as significant sources of GHG emissions and air pollution. Other sources of emissions of polluting substances and subject to regulations in gas processing are the fuel combustion in turbines or engines, sulfur recovery units, and loading operations. Methane is highly in focus, but carbon dioxide, VOCs, sulfur dioxide, etc., H2S, and mercury, as well as the BTX, must be controlled as well. We have available in Norway a set of regulations and economic instruments for keeping low emissions. But we have also tough goals with regard to reducing climate gases. And the oil and gas sector is our main source for climate gases and main target for the reductions. So we need both reductions and we need both regulations and economic instruments to achieve this goal. As we discussed the first day here, the EIA is a key to get it right from the beginning. Even if other regulations are missing in the country, the EIA process is suitable for us regulators to putting pressure on the developer to come up with the best solutions. In my experience, in most cases, will the EIA, and of course it should, conclude that the proposed mitigation measures will ensure that the environmental impact for a particular project is modest. However, this is not a guarantee for that the best available techniques to minimize emissions have been chosen, and we should push for the best solutions. So even if we as regulators don't have the necessary knowledge about alternative technologies, we can require that the proponent deliver an assessment of available technology or techniques and his justification of the choice made. What else comes in handy in our regulatory system is the HSC regulations. These regulations stipulate general and basic requirements for the operators in all phases of the oil and gas industry. They establish principles for environmental management, responsibilities, including contingency plans and documentation, and it is convenient and efficient for the operators to know these requirements prior to planning projects or activities. A general rule in our regulations is that they are not prescriptive, but performance-based. We do not prescribe a certain technology. I think that is, common these days, that we do not do that. Similarly, we have also regulations on waste, and that these regulations apply for all sectors and are also common in Europe. And it's it is very convenient for us just to refer to these waste regulations rather than stipulating conditions on a case-to-case basis with regard to managing the waste and where it should be delivered. We have also economic instruments for dealing with carbon dioxide in addition to the emission trade system. The costs for buying quotas for CO2 emissions are increasing heavily these days and will result in measures being implemented to reduce emissions, which is the purpose of the system. And finally, we issue an environmental permit for the actual operations. in this permit, we detail some requirements, in particular on chemicals, and also plant-specific emission limit values, if not regulated otherwise. Yeah, so I don't know what red. What have I done here? Well,
okay. You can see, so it's okay.
yeah. BAT is the keyword for the regulators, and we put efforts into make sure that BAT is selected when a new project is being planned. And the EIA scoping process, which I think you are familiar with, is the right timing, the right place for ensuring that BAT will be a part of the EIA study to be delivered. And it's the operator, the proponent that delivers, are responsible for the EIA study. Because it's good to have it right from the beginning. It is a lot of possibilities to recover waste gases from new facilities. But when you are dealing with existing facilities and there is no modification project going on, recovery is technically possible, but can have very high abatement costs. So you better have it right from the beginning. And I would like to, since we discussed BAT earlier today, I will just underline that techniques also, like Esam said, it includes both technology, but also the way in which the installation is designed, built, maintained, operated, and decommissioned. So it has more to it than only the actual technical device for a certain operation. But how to assess BAT? As regulators, we cannot have the full overview of available technology techniques, and neither has the project planners. So in order to assist parties here, the European Commission, EU, has developed so-called what we call the BAT reference documents, in short BREFs. And these documents, which are quite heavy technical documents, but it is possible to go through them. They describe and evaluate different techniques and the associated emission levels in a quite detailed way. And these documents are specific for each industrial sector. There are BREF documents for refineries, and that particular document includes also gas processing. And there is a special document for large combustion plants, which also will be a part of a gas processing plant. For exploration and exploitation of oil and gas, there is a quite new document which is slightly less technical than the other BREF documents, but it's still very useful. The reference is on this slide. And the document contains a lot of more detailed reference material, but I think it is a valuable document for you to look into. It's not so difficult. There are other technical guidance documents also on what is BAT. For example, the Climate and Clean Air Coalition and the Oil and Gas Methane Partnership has issued a lot of technical guidance documents. This one here is on glycol dehydrators in particular. So they can be quite useful, and these organizations are very eager to have these documents spread and distributed and used. We have made in Norway reporting guidelines on venting and fugitive emissions. And we have a very strict regime on reporting. And this guideline will make us, we will make sure that all the operators, they calculate emissions in the same way. So it's a quite, we have done a lot of work with regard to achieving better emission data from the operators. And this document includes source-specific methods, including measurements, calculations, modeling, depending on the actual source. So the recommended methods are described in this document. The manual targets emissions of hydrocarbons from venting and leakages, mainly. Compliance monitoring, that is a very important part of the regulators' work and regulations, enforcement of the regulations. We have a quite good relationship and a good dialogue between operators and regulators in Norway. But the regulator's role is clear and professional. We do not mix the roles, even if we know, if Norway is a small country and we always meet somebody we know at the other side of the table, but we still strive to be very professional in our role as regulator. The compliance monitoring system is based on that the operator submit a very detailed report to our agency. And this report comprises emission inventories, results of monitoring and measurements being done, inventory of chemicals and energy consumption, and also about a record on non-conformity incidents and more stuff. And there is audits and inspections. It's an important part of our work. We do not undertake audits and inspection necessarily at the fixed frequency, but we use a so-called risk-based approach that our priorities will be where the risk is. We consider the risk to be highest, the risk for pollution, and that the operator is not doing very well, has not proved to do very well. We also use campaigns. In that way, we write letters to all the operators, and they shall answer specific questions within a certain time deadline. And we are required them to ask, to respond to our questions. Again, we put a lot of efforts in being professional when we are carrying out the audits and inspections and in the following up on the findings. I will mention it's quite interesting and newly proposed regulations, both in EU and US. And the purpose of these regulations, they are separate regulations, but they are quite similar. What I think EU has been inspired by US in this case. The purpose of the emissions, of the regulations, is to control emissions of methane from crude oil and natural gas extracting and pipeline transport of natural gas and distribution. The regulatory approach is a very strict regime for the operators to undertake leak detection and repair, calculations and reporting, verification by measurements, for example, optical gas imaging cameras. The regulations will obviously level playing field for the gas producers all over Europe and US, but they will be very demanding for the authorities to follow up, as it prescribes how often we shall carry out inspections and receive and respond to reports from the operators. So that this is not in line with our normally regulatory approach in Norway. So we are not too happy about it, but the intention is very good and the necessary requirements for the operators is very good. But we like to have a little more freedom as regulators to how often we shall go out on inspection. So here are some examples of our regulations of NOx and SOx emissions to air. The exhaust gas is regulated by standards concentration limits as found in the EU BREF for large combustion plants and refinery BREF, as I mentioned previously. BAT is low NOx burners for boilers and dry low NOx emission DLA gas turbines for new installations. And that is a fact. Here I recall Esam's talk yesterday about ambient monitoring. And we also require monitoring of ambient air at industrial sites of a certain size, for example, large gas processing plants. And the actual requirements should be based on local conditions, taken into account weather conditions, population density, and other emission sources in the area. So I think we are very online here. And the heights of stacks was also touched upon yesterday. Dilution is not the solution to pollution, but you still need to have a certain heights of stacks. But of course, before you do that calculation, you shall use BAT to reduce the emissions. But after that, you will need to have a certain heights of the stacks. Also, discharge of water is very important, and all waste streams shall be treated before discharging and disposal. The same EU BREF documents I referred to stipulate also standards, concentration limits for a long range of chemical parameters. For example, total organic carbons, oil, benzene, ammonium, lot of chemicals. And the standards, they reflect what you can achieve when you have an efficient wastewater treatment plant. And if you have a very sensitive receiving environment, you may even put stricter limits on the wastewater. So I come to my final slide. I have to mention the carbon capture and storage, since that was part of the discussion yesterday as well, the amine absorber. So we have 2 gas facilities in Norway capturing carbon dioxide from produced natural gas, or call it associated gas, by using, no, this is natural gas, by using amine technology. And the captured gas CO2 is disposed in geological formations below 1,000 meters below the seabed as the final disposal. So the CO2 is not used for EOR, so it has no value. It's merely a way of getting rid of the carbon dioxide so that the operator doesn't have to pay the CO2 taxes for it, and it looks good on the national inventory of emissions of carbon dioxide. So by this technique, 1.5 million tons CO2 per year are geologically stored instead of being emitted to the atmosphere. And there will be more of these CCS facilities in the future. Yes, that was all from my side now. Thank you.
Thank you very much, Anne, for your presentation. Thank you so much. I think I picked something from it, that the audit and the inspection should be risk-based, we shouldn't just get up and say we are going to do inspection, but we should do risk-based so that we'll be able to identify the issues and address them. And also the BAT is to be selected at the design stage as we are doing the EIA, so that we'll be able to get the best as we are identifying the issues. We'll try and make sure that the BAT that we are choosing can also address the issues. So thank you very much. Please, if you have any question, you may raise up your hand or mute yourself, or you can also put it in the chat. Any of them you can ask your question. Either you put it in the chat box or you mute yourself and ask your question before Anne leaves us for SM to join us. Any question?
Yes, I have a question.
Okay, please.
Yeah, she said that the flood has been prohibited in Norway. So I want to know which of the flood that has been prohibited. Is it the steam one or the fire one? And if it's the steam one, what are the impact it has in the environment?
Okay.
Thank you.
Do you have another one? So that you can take them? Okay, and you can come in.
Yeah, I'm not sure if I got your question correct, but it's the operational flaring, the routine flaring that is forbidden. So it is still allowed to have safety or emergency flaring to a certain amount per year. But now it's new plants will have closed flare so that they are recovering the flare gas, and very seldom will need to actually flare.
Okay. Please, are you okay with the answer? All right. I have a John, you want to come in? Hello, John. Do you want to ask a question? Okay, I have one question in the chat box. The aspect of carbon capture, what exactly happens after the capture in terms of disposal?
Yeah. The CO2 from the amine unit is compressed. It is a gas stream containing 99 or 90, about 99% CO2, and that gas stream is compressed and injected into the underground to 1,000 meters below the seabed.
Okay, thank you. Someone also wants to know more about, you say if you can elaborate more on carbon capture mechanism, the mechanism.
Yes, the reason the natural gas contains CO2 in the concentrations of between 6 and 9% of CO2, and that is too much for having it into a processing plant or for to export it as a sales gas. So the CO2 has to be reduced in that gas, and they put it through an amine unit where you capture where the CO2 is absorbed, and later you can heat this unit and the CO2 will be released again, and as a concentrated CO2 stream, and that is what it's compressed and injected into the underground, and it shall stay there forever. That is the point.
Yes. All right, thank you. And someone also wants to know, so from the presentation, you stated that 1.5 million tons of carbon dioxide is displaced yearly. Is there a maximum limit for carbon dioxide injection per year? Do you have a limit cap on it?
Yeah, actually, it has been considered that this reservoir will have the capacity for receiving this amount. So it's designed. It is designed the whole system for that amount. So it is also a limit.
Okay, thank you. And I think the last one, We want to know about the carbon capture through amine technology.
Yeah, I think then we will have to send a link.
Okay.
Yeah.
Okay. All right. Is there any question from
Bernice? I'm also sending a handout talking about this.
Okay.
Thank you.
All right. Okay.
Yeah, Canada is also great in this. Very good.
Okay. Gaspar, please, you can unmute yourself and come in.
Thank you. Good afternoon, all. Yeah, I would like to know what is the implication in the future to store this amount of the quantity of CO2 in this geological formation, regardless the depth of those structures. Is there any consequence in the future if the answer is true? I would like to know what implication or what consequence can be to the environment to store this amount.
Yeah, there should be no. It has been studied a long time in advance how this CO2 will behave when it is after it has been injected. So there are quite good models for how it will migrate within the formations that has been found, and there should be no leakages, and the CO2 can be followed by seismic surveys, which is taking place every third year, that you can follow, actually see how the CO2 will disperse in the formation. And it has been there should be no way up to the surface, so we consider it a very safe method, but it has to be chosen carefully, the formations to be a target for injection.
Okay, thank you. I think the last one, then we'll move on to Esam. Mohammed wants to find out if capturing of carbon dioxide worth anything, or if it's beneficial. That's what he wants to know.
For Norway, the benefit of it is that they don't have to pay the CO2 taxes or buy quota, because there is no emissions. Otherwise, if they had let it out to air, it will be very costly for the operator because of the taxes and the quota system. In Esam's place, I think he can sell the captured CO2, but for EOR purposes, but we haven't that system. So it's a saving of costs for the operator.
Okay, I think Esam wants to come in.
Yeah, actually in Alberta, we cannot find enough CO2. Thank you.
Okay, so because of time, let's move on to Esam's session. Thank you very much. And Esam, please, you can come in. Hello, Esam.
Yes, I am here. I am just preparing my presentation, sorry. So what I did is I went to the presentation mode. Now I have to go to share the screen. Let me see, how am I gonna do that? So share screen, and I guess I am on. What do you think?
Yes, you are on.
Yeah,
Yes,
looks
you
good.
are.
Perfecto, perfecto.
You have to
in the presentation mode.
It is not.
Yeah, but you have to,
Oh.
I think, two screens. So go to display settings, and duplicate screen, Esam.
Display settings. Display.
When you go to presentation mode,
go
to presentation mode.
Okay.
And then you just click on display settings.
The presentation mode, and then I have to go to okay, display settings. What? Here, and
Yes.
then I duplicate
screen, and then share your screen. And then share your screen.
Okay. Then I have to go to, I think I'm missing something here.
You have to share screen. First share screen with us.
Okay, first share screen.
Okay. Then go to presentation mode.
Presentation mode, okay. It is going. Yeah. Okay, then go to display setting and hit duplicate.
Yes.
I think it's okay when you go to presentation mode, you'll be fine.
Okay, how about now?
Yep.
Yes.
Okay, so and module number 3, we wanna have an overview of the global and local standards for treating associated gas. We wanna discuss the global standards and the national standards and regulatory practices, as well as, let me minimize this here, come on, and identify potential areas of improvement. So whatever available in certain country, can I basically, what does it mean here, the description of the module is, can I copy that to my country? Well, let's see if we can do that. Now in Alberta, as an example, Alberta is actually utilizing and adopting the continuous emission measurement systems. And this is only for stationary sources. To elaborate more, stationary source means any equipment that sits there for a minimum of 10 years. So if this equipment is sitting there for a minimum of 10 years, then it is a stationary source. Accordingly, it has to be monitored and controlled through the continuous emission measurement system. Now, when we talk about system, when we talk about code, later on I'll start talking about acts, all of those are actually laws. So we are talking about a governmental law actually that handles all of this. Now the code of the continuous emission measurement system has also a few pillars associated to it. One of them is the quality assurance, the quality control plan must be in place. So what we want to say here is in Alberta, when we are adopting the continuous emission measurement system, we also adopt quality assurance and quality control plans into that system. We also adopt the idea of a daily validation, regular inspection, maintenance, auditing, reporting. All of those are also adopted as well. So the continuous emission measurement system has all of those kind of items inside it. Considerations include the need for a representative sample has to be also in place. Now, as a regulatory officer, when you have a system in place, that means you are measuring all the operators, all the operations according to the same level. So you are not actually, you are not flexible. You have a baseline and you actually maintain that baseline, and then you compare all your projects and locations according to this baseline and according to this reference line. Depending on the industry in general, as I said before, we require a permit. That's good. But the permit has to have the details in it. It has to give the operator the head-ups about what the regulatory officer or regulatory bodies, what do they actually expect from that operator? What is it you are going to measure? It has to be mentioned in the permit. You have to mention, you have to measure this, this, and that. Like, for example, we spoke about sulfur, we spoke about CO2, methane, particulate matters. all of those has to be mentioned in the permit. So the permit is not a piece of paper, one piece of paper that says so-and-so operator is permitted to do 1, 2, 3, 4 in a certain location. No, it is more than that. It has to set the standards and the procedures, and it has to set also the requirements from that regulatory body. Then the operator and the regulatory body, they are all on the same direction. The permit also determines how do you report, okay? And also mentioned about a system, a reporting system. Yes, we do have the same in Alberta. There should be a way to report whatever the permit needs. For example, the permit is saying, Mr. Operator, you have to measure CO2 every day. Okay, wonderful. How? Well, you have to choose. The permit has to tell the operator as well which method to use. And then the permit has to tell the operator how he, or I mean the operator in this case, how the operator will be reporting those. Also, the permit has to say what kind of standards they are looking for. If you guys remember, we said the commodities are measured either in part per million, that we can also measure them in tons, kilograms. Okay, what does the authority, the regulatory authority, what do they expect to be measured, and how do you report it? Are you reporting it as a percentage? Are you reporting it as part per million? Now, do we do an audit? Like, how do you make sure as a regulatory body that the operator is basically doing what agreed on in the permit? So do you need a third party validation, auditing, maintenance? What do you need? And how often? Those are a very important information for a regulatory officer and the regulatory body. We must identify all of those at the permit level rather than at the actual operation level. The continuous emission measurement system is also telling the operator how to measure the commodity, how to measure the concentration. When I say how, I mean the tool. What is the science? What is the tool that is acceptable by the regulatory body or entity? For example, I'm listing here some of the stuff we use in Canada. It's not exclusive though, you can change that. But in general, we ask the operator to measure the SO2 by something called UV absorption. The NOx by the absorption or the chemiluminescence. The CO and the CO2, there is a technology called NDIR. Opacity is used for particulate matters. We are not telling the operator where to buy those devices. No, as long as the operator is following the permit that we gave him, we are fine. All what we need is measure this contaminant this way by this tool, and this is how you report it to us. So the permit in this case is more or less an agreement between the regulatory body and the operator, in which the regulatory has to tell the operator what to measure, how, when, how to report. All of those details must come in the permit as well. This is what we call it, continuous emission measurement system. Okay. Now, one more thing to say is when we say the word continuous, that means we are expecting the operator to measure those values always. Continuous means within a certain period of time, always we have a reading, we have a value. and this value has to be reported to the authorities. Why are we doing that? Like, why do we care about that? Why not to tell the operator, listen, measure it once every week, and we are okay with that? Well, this is a process, and the process has upset conditions. So it's not always the same. It will go up, it will go down. Now, when I look at the report that comes from a certain operator, and I will see that sulfur content is more in so and so days, in so and so time, that means it gives me a clue on what's going on in that facility. Why at that time we are always finding and seeing high sulfur values? Why? Is there should be a reason for that. Then again, the regulatory officer in this case has to advise the operator with the findings, with the notes, and demand clarification. In this case, you are applying a full monitoring process for the operation itself to make sure that nothing is going right or left during the day or during that period of time. How do you sample? Like, how do I take a sample? All of this has to be mentioned in the continuous emission measurement system according to the authority, whatever you are adopting in your country. It has to be referred to in the permit as well. So we need to tell them, listen, you have to do the sampling for H2S by the in situ measurement or by the extracted measurement. What is in situ? Well, in situ means you have a probe sitting in that particular place always. And this probe, every, let's say, 5 minutes, takes a reading and send it to the, I would say, a computer. And this computer will record it. And then at the end of the day, or at the end of that particular period of time, all of those readings has to be reported to the regulatory officers. Measurement, how do we do the measurement? Where is exactly I'm putting the probes? All of this is mentioned. I mean, in Alberta, it is mentioned and under the SEMS code. So again, let me remind you and remind myself that the word code means law. Okay. The extractive method is also recommended. Look at this diagram. Let's have a look at where my mouse is. In situ point analyzer. Okay, so here we have the continuous measurements by having a probe or analyzer all the time sitting in that particular location. The other technique, if you look down here, is the extractive analyzer. Means I will take a sample, then I will run tests, and accordingly, I will report. Both of them are required in certain industries. One of them is required. Which one is more better than the other? It depends, again, on the project, on the technology, and, of course, the location. For example, if I am near a river, and this river is actually feeding and watering the whole city, well, what do you think? Shall I take sample every week? Shall I do a continuous sampling system? Well, the location is basically is a health concern because it's near the river that feeds the whole city or the whole province. So I should actually pay more attention to the environmental concerns. Now we are talking about health issues. We are talking about social issues. Plus, of course, at the top of that is the environmental issues. So what I want to say is, whatever the system you are adopting, please be flexible and always remember the technology we are using, the project, and the location in that country. Whatever available, whatever suitable actually in Alberta may or may not be suitable in Ghana or in Norway even. The particulate matters, we said they are measured by a certain technique. It's an opacity technique. Basically, what we do here is we measure the particles, okay, by light. So this is one of the techniques we are using. The code, again, the code, which is the law, by which the continuous emission measurement is designed and installed and operated, it has to be agreed on with the operator and the permit. Okay, so all of those details. So again, the permit is not only one piece of paper that tells the operator, okay, you are good to go. No, it has to tell the operator exactly how to measure things, how to report, all of those kind of things. In case there is an issue, the regulatory officer found that, you know what, this reading is out over the limit always. Okay, and what shall I do? Well, just ask for a sample. And this sample has to go to a third party. This third party will identify the values. And then, of course, they have to be compared to the local standards. From there, you can determine whether this operator is actually following the permit, or unfortunately, there is something wrong that has to be adjusted. Those are, again, the ways of measuring the values we have: linearity, relative accuracy, bias, all of those. Now, what I want to say here is this terminology, and those are the techniques we are utilizing here in Alberta. I'm just giving you an idea about what do we have in our regulatory bodies. How do they do business? How they do the work? So probably you want to take a look at all of those. And before I finish this presentation, I will tell you exactly where you can find all of this. Okay. Those are values that we give the operator, and we ask the operator to stick to those values. Now, look at this little trailer. This little trailer is a third-party trailer sitting on a site and measuring all the values we want. Air quality, this is basically this is for air, for H2S, for CO2, for particulate matters, for different values. It is not expensive to have one of those on site. Okay, it is, and those trailers are actually well designed. They are actually well equipped with the recent techniques to measure the values that matters for that particular project. We always talk about ambient typical conditions. So how do we measure that? First of all, what do we measure? Well, we measure H2S, SO2, NOx, SOx, ozone, total hydrocarbons, and total hydrocarbons are more into the associated gas as well. VOC, green gases, total suspended bar, all of those values can be measured through the ambient techniques. The wind speed. Okay, why the wind speed is important? Like, why do I need to measure the wind speed? And why I have to mention it in my permit? And why should I, recommend to the operator to do it? Well, it tells you how fast things can move and in which direction. Accordingly, you can determine whether the values you are getting from the monitoring system, whether it is suitable for that location or not. Again, we are talking about location, we are talking about projects, we are talking about a country, technology. So in some of the locations, you may need this technique, and others you may not. So all of those are available. You can utilize them basically Again, depends on your country, depends on the project, the technology, the location. And let's all remember that the permit is attached to the location. It is not attached to the company, meaning when you give the operator a permit, that operator is permitted to operate in a certain location. If that operator will move, then another permit has to be processed and issued. The permit is always attached to the location. Please remember that. The fugitive emissions, like mainly leaks from pressurized process equipment. Well, what's a pressurized process equipment? Well, compressor. All of the compressors are subject to leaks. That's why they require, I would say, a more focused monitoring system. Okay. The techniques to measure the fugitive emissions is through the spectrometer, open path devices. There are several of those techniques available. And again, are they expensive? No, they are not expensive, but you should have them to make sure that the operator is actually following the permit. Acid rain, how is it formed, the chemistry behind it. Of course, we are all familiar with that. I'm not going to go through them, but I just want to, the reason why I put the slide here is in most of the countries that I'm aware of, they think that acid rain is always there, cannot be prevented. Okay, what am I going to do about acid rain? It is always there. It comes from the cars, it comes from power generation. So why you are focusing more on the oil and gas industry and mainly associated gas? Like, how can I tell everybody that associated gas is not similar to any other technique? It is not as the power generation activity. The associated gas may have more sulfur in it than any other process. So in this case, the acid rain will be very important to take care of. Again, where is the location? Am I near a river? Then if I have the acid rain coming down to the river, it will end up in every house in the city. Now we are talking about social, we are talking about health, and of course, at the top of that, we are talking about environment. Sulfur emissions in general, they will form some psychological effects, some health concerns, social. Of course, the operator needs to know that if he releases sulfur to the atmosphere, then he will get it back in terms of corrosion. Okay, so it's actually for the operator's benefit, as well as the country benefit, as well as the people benefit, to stop sulfur emissions, mainly. Nitrogen oxide. Nitrogen oxide can have different effects. That's why we care about that particular contaminant. There are lots of solutions how to capture nitrogen and what do you do with it and how you can utilize it. I think module 2 was full of those alternatives. The most important thing here, if you guys remember the smoke is a word that was derived from smoke and fog. And if you guys still remember the picture in module 2, where we shot the city of Calgary with all of those fumes at the top of it, and we said smog is a problem. Because if you guys remember the clever person who decided to build a taller stack, and he said, you know what, let's send it to the high level, and then dilution to pollution is a solution. Okay, now in Canada it didn't work because we have a very cold climate, and all of those I would say pollutants, they will come back. They are not going to be released to the atmosphere. Green House gases, we are all familiar with it, familiar with the effect. I just want to say that we also consider water vapor as a major, we actually forgot to talk about it in module 2, so I got the chance to speak about it here. Water vapor is always considered as a pollutant as well. So where is it coming from? Well, remember guys that the dehydration unit is there. Dehydration means I remove water. Also the amine unit is another source of water vapor as well. Um, what are they responsible of? Well, you know that the greenhouse gases are very nowadays. They are responsible for several concerns, environmental concerns, and other concerns as well. We do have implications. I mean, it's proven now that those as well they affect the human health as well. The ambient conditions also applies for water quality. Remember, we spoke about air, humans, air, water, earth, and other living partners. When we talk about water, we do have um, major concerns environmentally and also health-wise for the water that comes out from associated gas. Remember, we said associated gas may have some water content in it. Okay, what do you do with this water? You can I just dump it in the nearest river? Can I just throw it in the nearest sea? Or maybe there is also another clever person who decided to drill a hole and just dump that water inside, leave it there. Okay, well, if you don't see it, it does not exist. But that's wrong. If you don't see it, it exists, and maybe you do not see it today, maybe you do not feel the effect today, but believe it or not, it's coming. So we have also to deal with the water quality as well. Those are some examples about the water qualities and what do we actually look at when it comes to the code that we are talking about. Let's look at the industrial in general and also the associated gas industry. What do we want to accomplish? Well, we want to look at the regulations. We want to look at the environmental assessment approvals. And the most important thing is the enforcement. Now, why I'm saying it is the most important thing? Well, believe it or not, guys, we have the regulations, we have the assessment, we have the approvals, but after that, there is no enforcement. Okay, there is no follow-up. And I refer to Anne's presentation when she said there should be reporting and there should be also some inspection. Okay, so site inspection is very important, whether you are talking about ambient, whether you are talking about continuous, it doesn't matter. You have always to inspect that the site is following the agreement. Okay, what do you mean by agreement? Do you guys still remember the permit? That is my agreement with the operator. I just want to make sure that whatever we agreed on is already enforced. Okay, we do have a fancy environmental laws in place. Are they enforced? And if they are enforced, are they inspected? So the role of the regulatory office does not start and end in the office. It actually starts before and even after. Okay. Most of the countries, the regulatory authorities are governmental, following the government ministries. And when I say that, I mean the Ministry of Environment, Agriculture, Health, Transportation. Here in Canada, we are talking about the Transportation Ministry to be part of the whole matrix. We also consider some independent agencies. I'm giving an example here, like the National Energy Board, the Environmental Assessment Agency. Those are also identified independent agencies. They work together with the ministries and the operators in order to achieve the, in order to achieve a clean environment and a safe projects after that. I don't know in your country, what is the situation? Is it only government bodies? Do you have a third party? Do you have independent agencies? Now, why do we have independent agencies? Like, why not to just have government? Well, because you need remember when we spoke about a third party validation? You need those guys. So you have to build an independent agencies that are qualified enough to say, yeah, you are doing a good job, or no, you are not doing a good job. Now, what I want to talk about last is the acts. In Canada, act again means law. Okay, so we do have in place, we do have acts and codes about almost everything related to environment. Everything, quality of water, quality of air, earth, everything. We always refer the operator to those acts. We tell the operator, okay, if you wanna start a project, please take the act and design your project from day one following those acts. The act can be up to 400 pages, can be as small as 20 pages, but it spells out everything that matters for a safe and environmentally friendly associated gas developments. So before you ask the operator to follow a standard, we need to tell the operator what will happen if he followed the act, followed the standards, and what may happen if he doesn't follow the standards. So the standards are there. Okay, are they enforced? Yes, they are. Well, are they published in a law, an act, a manual, whatever you want to call it? In Canada, we call it act and code. The government bodies enforces regulatory compliance under the Environmental Protection and Enhancement Act. So we have to enforce. How? Well, by inspection. So you inspect. Okay, what will happen if you find that the process is not up to your expectation? Well, you have to initiate an investigation stage. Okay, then do you guys remember the independent agencies? Well, that's a compulsory monitoring. And then you have to agree with the operator on how do you reclaim, how do you solve this problem. This will give us back or put us back to the best available technology or best available technique. Mainly, if you are talking about a project that is really old, still working though, but it is old. So how do you actually bring that old project to today's standards? Well, you need to do the monitoring, and you need to do something called reclamation programs. And again, in Canada, we spoke about the acts, and we said the act is a law. I am just giving an example here about the Climate Change Emission Management Act. This is one of the most important acts when you are seeking a new project and with associated gas development. We also have several ways to express to the operator on how he can assure that his plant or his design or whatever the operation he's doing is basically following the code and following the act. Let's remember that you either or have a continuous emission monitoring system or ambient air quality objective and guidelines. So both of them has to play a role and your monitoring plan. So hopefully we got a very quick understanding about what is available in Alberta, Canada. What do we adopt there? How can we build our own standards and our own monitoring system? How do we do that in a country that does not have it already? And if you have regulatory measures, okay, can you add to it to achieve a better, safer, and more environmental friendly projects and developments? Everything goes back to the module 2 when we talked about the BAT, when we said the best available technology is always, or should be always there, because it is changing and you have to capture the best available technique to mitigate and eliminate your issues, your environmental issues. We have to consider the safety. We have to consider the SOPs that we talked about in module 2 as well. Let me remind myself and let me remind you guys that there's always a government, there is always operators, and the research institutes, whether they are governmental or universities in this case, they are all has to play a role in a safe and environmental friendly associated gas developments. The one of the things I want to talk about are I will stop sharing the screen and I'll go to another share if you don't mind. I think I still have a couple of minutes here. So let me share with you how do we actually do the inspection? Like, what do you mean by the inspection? Well, the inspection can be as easy as this. Look at this little video, please. Let me see where I can find it. Share sound. I don't know if I find it here. Maybe here. Do you see this? Bernice, do you see my video, please?
Not yet. You are now locating it. I can see your desktop.
You see, you can see my desktop, so that's not what I want.
Yeah, we can see the file explorer.
Yes.
Okay. So let me probably open the video first.
Yes.
Let me go back. Then I will minimize it. Go to share. Okay, I cannot see the video on my shared screen.
Okay.
I don't know why. But anyways, what I wanted to show you guys is actually a regulatory officer visiting a site to verify and inspect that this site is following the permit or following what was agreed on with the operator. Anybody can help me? How can I actually share a video?
So are you sharing from YouTube?
Maybe files, I don't know, basics. I don't see it.
Hello,
yeah, I don't see the video.
You don't
Sorry
see the
about
video?
that.
Oh, okay. Have you saved it on your desktop?
It is already saved on my desktop.
Okay, so open it first.
So you see my desktop, I believe, in front of you. It is this video.
Yeah, try to click it now. Try to click it now.
To try what? Sorry?
Try to click on it.
I am clicking on it. Do you see it? Do you see that video in front of you, or
we hear the on? We hear the sound. But
what about this?
So I think you should open it before you share.
Well, this is what I did. It's actually, so if I want to stop sharing, I'm sorry about
by the noise, it looks like the video is already open. Can you minimize your Explorer?
Okay, I will open the video And then I will go minimize my Explorer. So let me minimize this as well. I am back to the main screen. So do share screen. The issue is I cannot see the video on the list of files that I can share with you guys.
It could be a bandwidth. It could be a bandwidth issue.
Anyways, the idea, Marisol, was to show that there is a regulatory officer going on site. He has a tool with him to verify the numbers that the operator is sending to the regulatory bodies. So it is part of the inspection technique, and it is agreed, should be agreed on with the operator, that the regulatory body has the right to send an officer, whether this officer is coming from a third party or whether this officer is actually coming from the same regulatory body. They have the right to do that, let's say every so-and-so days, months, hours. It's up to that particular regulatory body. Let me remind myself and let me remind you guys that the project location, the technology, the country itself, they are all unique. So we cannot generalize. I cannot say, well, I'm sending or I need to do the inspection once a month. Well, once a month maybe is suitable for a certain location, but in another location, it has to be once a week. Okay. So ultimately, what I hope that I achieve today is some sort of comparison between whatever the standards you have in your country and what is available in Alberta, Canada, as an example, of course. And if you are missing something, you can always refer to the nearest country or the country that, for example, Norway, they have a very advanced acts and laws when it comes to the environment. Let's always remember that the regulatory body is not policing, is not controlling in a bad way, but it is your job to make sure that everything is done right from the first time. Appreciate it. And I'm sorry about the hiccup of not being able to share the video, but maybe we can put it somewhere in Google Docs, and Taylor maybe will help me with that and see if you guys can see the video individual. Thank you, Bernice. I'm giving back the mic to you, please.
Thank you, Sam. Thank you very much. Marisol, please, will you come in?
Yes. Hi. So I think there are a lot of questions now that has been generated, actually, also coming from the presentation of Annegret as well, about inspections and auditing, and maybe let's kind of take a step back and just get our feedback from Annegretta and Essam about, you know, how does that work? How is the environmental compliance monitoring organized, and just tell us how it's supposed to work and how is that. Annegretta, I'll start with you.
Okay, thank you. I think it's important for us to be quite clear that it is the operator's responsibility to ensure compliance, and it's important that the operator has in place systems for monitoring, etc., and so we can inspect those systems instead of going out doing monitoring measurements ourselves, because that is takes a lot of resources. So we try to put as much responsibility to the operator as possible. So yeah, so that's for one thing. I stop there.
I also understood, I think in Norway, that you, for audits, which is more a detailed sort of inspection process, that you actually conduct these campaigns once a year on certain thematics. So maybe you could just give a sense to our participants on how you do that.
Yeah, the audit is very much paperwork, or we have to prepare by asking the operator to send us a lot of procedures. For example, with regard to the leak and repair detection program. So we study that program, and then we interview people on site on whether they are really following up their internal procedures. So that is how we do it. So we don't go out with measurements, monitoring systems ourselves. We study papers and do interviews, and then so that is the verification part. So it can take up to 2 weeks with preparations, actually interviewing, and making the reports and findings available.
Okay, great. I just turned off my video because I'm having some internet connection issues, but I can hear everyone very well. So I think this is the thing that we wanted to touch on, because it came up in the last 2 days as well, about the roles and responsibilities of the different key players here. So you have the operator and the regulator, and ESA made this point that you should try to also have a constructive relationship with each other, in terms of you're not policing or you're not stopping per se, but trying to enable and get the best practice as possible. SM, could you just maybe share from your own experience as well, because I think you've had enough experience in the operator side, how your perspective on what's the best balance between regulators and operators with regards to applying best practice?
I mean, the operator and the regulator, they both need to understand that they are in the same boat. They share the same environment. So if the regulator is telling something, the operator needs to listen. Okay, that's number one. So the mindset of that, the idea that the regulator is actually controlling, or he has the upper hand, no, that is not valid anymore. We are both, we all live in the same environment, and we deserve the best for the operator and the regulator. At the same time, the regulator is not a brake. The operator is basically want to push the vehicle forward, but in a safe and environmentally friendly manners. When it comes to the relation, there will be always conflict between both of them, okay? But conflict has to be looked at as a healthy thing, rather than just a conflict for the sake of the conflict itself. The operator and the regulator, they both work to push the vehicle forward. At the same time, they both care about the environment itself. So the relation between both of them has to be identified, well identified in the law, well identified in the permit, and the operator has to understand that the regulator has the right to come in and inspect that everything is going the way it was agreed on. The permit is an agreement between the operator and the regulatory officers, or the regulatory bodies in this case. Thank you, Marisol.
Thank you, Essam. I mean, I think that's a good point to go back to, look at it as like a partnership agreement relationship. So I think that's a good point, basically using the permit and permitting conditions as as the main, basis of the agreement partnership, let's say. So are there any questions from the floor? I'm looking at some of the chat here, and if there's any other questions you wish to ask regarding, you know, this aspect of sort of governance and regulatory practice around these issues, feel free to raise your hand. I don't necessarily see a hand raised.
Could I add something, Marisol?
Yes, please go ahead.
Yes, just to say that it is not only the regulator and the operator. There are more parties to it. So as a regulator, I think we represent the community, the people, and so that we have a responsibility also towards the rest of the community, not only the regulator as such. Just
good point. Yes, absolutely, absolutely. Good point. Like local communities, of course, also have a say, and I think we touched on that. Somebody touched on that yesterday about, you know, grievance mechanisms and public participation as well in the EIA process. So indeed, that is also an important aspect.
Marisol, there's one question in the chat box. How is the wind speed and direction important in regards to pollution? I think this goes to Esam.
So basically, the wind speed determines how fast those pollutants can travel from one location to another. And the wind direction, for example, tells me if I have a pollutant at point A, is it going to affect point B? Now, that puts us back to the project location. How critical is the location? Okay, and this is more into the social and health side, because for the environment, whatever the location is, we have to preserve the environment. But it is more into the health and also the safety of those pollutants. Where are they gonna go? Let's remember the smog idea. Let's remember the photo that we saw for Calgary, where it is covered with that fog and smoke layer. It's very important for everybody to know those pollutants, if they happen in point A, are they going to reach point B, and how fast, and what is the effect on the health and the social life around the project? Thank you.
Thank you. Any other questions? There was a more technical question as well about the difference. I think it comes from Esam's presentation on quality assurance versus quality control. Do you want to elaborate on that, Esam? The difference?
So it's just similar to any other industry. What is the difference between quality control and assurance? Well, quality controls are basically the tools, I would say, or the vehicle you are using in order to determine whether the standards are there or not. Are the standards are followed or not? So quality control is more like the procedure. How do I do it? How do I make sure? Now, quality assurance is basically like an insurance plan. Like, is there a way to continue the standards, continue that the standards are followed? That's number one. Number two is it going to be always the case, or am I going to get it sometime yes, sometimes no? So quality assurance and quality control, they both play the role in making sure that the operator or the industry in general is following the standards of that country. Thank you.
Okay, thank you very much. I don't see new posts anymore. So I think we might have already covered many of the major comments. Unless there are last burning questions or thoughts? So I think what we can do is go for a short break. Allow our thank you, and let's have a round of applause to both our presenters today. Yay. Yes.
Thank you.
Yes. So, and then we will come back and just do a little bit more reflection about what bringing together everything that we have learned, and thinking about, you know, some of the next steps and how to address some of the key challenges that we can foresee working in this area related to associated gas processing and treatment. So let's come back, let's say at in about 15 minutes, and then we'll just spend a little bit of time to discuss together, and then we will go towards the closing. Okay, so so let's come back in about 15 minutes.
Hi, Marisol.
Yes, Bernice?
Would then be need for breakout rooms?
I'm actually debating about that still. Let's see.
Okay.
Let's see.
All right.
But we have it ready anyway, right?
I have to create it. That's what I'm asking, if I have to create it.
Uh-huh. Yeah, let's just go ahead and create it. Let's say 10.
So I will 10. Okay.
It's like it. Yeah. Thanks.
So yeah, okay, all right. Thank you.
All right. Good afternoon, everyone. So I hope you've had a good tea or coffee and managed to stretch your legs for today. So we'll start now with a bit of, this is really a way to kind of bring together all that we've learned in the last 3 days and really try to identify some of the key challenges in your particular country context, and also then what steps can be taken to address it. So let me see if I can manage to share my screen. And we'll go into breakout rooms again. So we at least we learned how to do breakout rooms yesterday. So hopefully it'll be much smoother today. Do you see my screen?
Yes.
Okay, great. So we'll go into, I mean, what we normally would do in a regular, training with smaller size, we would have country teams join together and do some action planning. But since we are quite a large group for this training, I think it's still worth coming together in mixed groups. So it doesn't matter so much your country, but this is really a way to also get to know each other in a smaller group setting and discuss. So what I would like for you to do is just, you access the documents that Taylor will share now. Like we have a shared Google Doc, which is very simple document, which looks like this. And then you will go into rooms, or Bernice will put you into rooms in mixed groups, and just spend the next 20 to 30 minutes discussing from your perspective and from your own country context what you see as priority challenges with regards to this topic, associated gas processing and treatment, that require attention. So you don't have to list too many, like 2 is fine. And what we will find is probably you have common challenges. And then you can also share, if you wish, some of the current efforts in your country that you are adopting to address that challenge. So it's a way to exchange experience as well. And then on the third column, I would like for you to reflect on what are the additional steps that you can take, in your current function within your institution, that you can take to address this priority challenge. So it can be as simple as, talking to your other colleagues, finding out what is the current regulation on this topic in your country. If you don't know, that could be an important step to take. So it could be very simple, but at least it's a very concrete step forward. Okay. And then if you have time, I mean, you can think of, okay, who are the focal points that you need to connect with, or lead institutions that will be involved. But this is not, if you don't have time, you don't need to do the fourth column. But it's just, if you can just spend a few moments discussing with each other the first 3 columns. Okay. And then in half an hour, we will come back, and then we will just do a sharing of what you discussed as a group. And then we'll move towards closing. Okay. Are there any questions on this? I'm going to come back to the room.
Okay, so should I open the room?
Hold on, not yet. Let's see first if there are any questions.
Okay.
So Taylor has shared the Google Doc for the groups, which you can access. I mean, they're the same document anyway, so it doesn't matter which document. But yeah, if you can share, and then we will assign you to any group. So doesn't seem to be any questions. So we will start the group work now. So I'll ask Bernice to put you into breakout rooms, and we'll come back in 25 minutes.
Can I get the link for group 6?
Yeah, let me share that with you. One moment.
Actually, I was supposed to be in 7, but my group was changed to 6, so I copied only 7 and 8 links, so not able to participate in the group.
Oh,
so just share me at least group 6 so that I can.
Okay, yeah, I'll send that to you right now. Okay, there's the Google Doc for group 6.
Yeah, thank you. If you can
You're welcome.
push me in group 6, I think I
and put you in group. Oh yeah. Oh, okay. I understand you. Okay. Yeah. So let's see. Let's see. I don't see what group you're in right now.
Taylor.
Yeah.
Please, can you send group 9 for me? Group 9.
Yeah. Group 9. Okay. I'm trying to put someone into a group real quick, but I can't find his name.
No, it's I have automated it, so the person will be moved. Don't worry.
You got. Oh, okay.
Yeah.
Okay. Here's the group.
Those who are not in group, they have decided not to join.
Yeah, that's what I figured.
Yeah. So group 9, they want their
I'm gonna put Felix into a group.
Okay.
Taylor.
Yes.
Will you please assign me in a group also? I don't know. Are we using the groups of yesterday? Because I was with the network problem when the assignment was done.
No,
okay.
you be assigned a group.
You assign me a group, please.
Yes.
You give me a group, please.
All right.
Okay. Yeah, it's different groups from yesterday.
Okay. So you assign me a group, please.
Yeah, we can assign you a group. I can't find.
Okay,
I don't see his name in the thing though.
I saw him.
Oh, I see it. Oh, he's in group 5.
You give me group 5, eh?
I think that's what it's assigned to. I can assign you to a different one. Let's see.
Yeah.
Here, try this. It should pop up on your screen. And you can accept to join.
Someone from Nigeria wants to be assigned to group 10.
Yeah, okay. Let's see.
Group 10. Which group is the person? So the person is no.
Name is, I can't see the full first name.
I think Nigeria, right?
It's Nigeria, NMD.
Okay.
Let's see.
You're supposed to be in a group already.
Oh, here he is. He's in group 8.
Oh, I see it. Yeah. Mm-hmm.
Okay. And you want to be in group 10?
Yeah, I moved him.
You have moved him. Okay.
Hello, Taylor. Can you hear me?
Yes,
I can hear you. Yep.
Please, can you assign me a group also? I don't have a group.
This is Felix.
Oh yeah. Okay, I thought I assigned you to a group. Let me see here. It says you're in group 4. Let me see if I can move you to a different one. Okay, I just assigned you to a different group.
Yeah. It's not critical to join the group, but it's just more to give you a chance to meet other of your peers and discuss together. But you can also choose to do it on your own.
I may join group 5, right?
Yes. Mm-hmm.
It looks like we have more in the groups. I have only 20.
Thanks, Taylor.
Oh, yeah, you're welcome.
I hope you can maybe if you want to grab a coffee or a tea, we'll hold down the fort.
Okay. I should be good for now, but thank you.
Okay. Bernice, SM sent the video, and I sent you a message on WhatsApp too as well. If you can just check, please.
Okay. All right. Okay. We'll look for it.
So please, are people back? We should send a message that we come back in 1 minute. Bernice? Okay, so I think we're gonna have people come back soon. Let me try my video, see whether the connection is better. Okay, my internet connection is really not so great today, but you can hear me, right?
Yes, we can hear you.
Yes.
Clear.
Yes, we can hear you.
All right. Sorry, I mean, I can't, somehow my video is sort of laggy. Let's see whether it will improve later. So welcome everyone. Nice to see all of you back, and I hope that was a useful exercise for you to at least get to know one another as well. So what I'll do now in terms of our sharing. So I mean, this is really, you know, this exercise is really for you to take back to your home country contexts and take it forward. I mean, this is really just giving you the opportunity to take the time to discuss with your peers and then get some ideas about how to move things forward. But let's have some sharing about what we've done in the group work. So I'll ask Taylor to bring us back to our Miro boards. And then I will call on some of the groups to share some of what you discussed.
All right, so just posted in the chat the link to the Miro board.
So,
and I'll also share on my screen as well.
Yeah, share your screen. Okay, so let's hear from some of the groups. What priority challenges that you discussed? You know, give us one or two. So go ahead.
Can I, Marisol?
Yes, please go ahead. Is that Salela?
Yes, speaking.
Yeah, go ahead, Salela.
Yeah, the issue of environmental standards for waste, air quality, and water for upstream for some countries are still inadequate or even lacking for that matter. And in terms of current efforts, is the ongoing amendments to cater for such gaps. And what probably we are doing at our personal levels is that we are trying to use what we've been learning through this particular several courses to address those gaps. Yeah, yes.
Okay, so environmental, hold on just a second. Let's give Taylor a chance to type. Okay, so like in terms of the challenges, is with regards to environmental standards for waste, water, and emissions.
Yes.
For waste, water, and emissions.
Yes.
Okay. Yes. So that's still inadequate. So it needs to be further strengthened. Great. Let me hear from Lucy from Nigeria. Go ahead.
Thank you. Hello, everyone. So for Nigeria, what we captured was we have to stop gas flaring and stick to the 2025 target to eliminate flaring. In 2020 alone, natural gas valued at $1.24 billion was lost from flaring, and this is equivalent to electricity usage for 804 million Nigerians. So, but there are current efforts in that direction, and there's a gas flare commercialization program, which is a gas to power initiative, which was launched in 2016. We also adopted the Flare Gas Prevention of Waste and Pollution Regulations in 2018. And one big win for us was the passage of the PIA in 2021. And the adoption of the environmental, the EGASPIN, which is the environmental guidance and standards for the petroleum industry. So we're seeing good strides in that area, but the major step to be taken is to invest to the funds that have been committed by the federal government, which is about $3.5 billion to generate 2.5 gigawatts of power, which will create about 300,000 jobs. If we invest those funds, it will provide clean energy to 6 million households and over 450,000 metric tons of LPG to over 4 million households. I think another additional step to be taken is to build capacity in green skills, especially in the public sector. The lead institutions are the IOCs, the regulator, where I'm working, that's the Nigerian Midstream and Downstream Petroleum Regulatory Agency or Authority, and the National Environmental Standards and Regulations Enforcement Agency. So these are agencies that are responsible to get us to where we want to be. So thank you very much.
Thank you. Thanks, Lucy. But can I ask you, did you discuss in your group like what actions you can take, like as individuals? Did you discuss that?
Oh, we didn't, but I can speak about that. I think what we're doing now is a major action that we can take, building the capacity, creating awareness that this is an issue, and especially for those of us working in the regulatory body like where I work, that governs all the petroleum activities for the midstream and the downstream. I think this is key, building that capacity, I think, and attending like what I'm doing now as an individual and going back there and just spreading the word. Thank you very much.
Great. Anyone else who wants to to share from their group? Like, what priority challenges did you discuss, and what actions did you think about for taking it forward? Can I have other volunteers to share from the other groups? From the other groups? Can I hear, let's say, the Trinidad and Tobago team? How about, let's put them on the spot as well. Can you share with us from your groups what you discussed? They might have some connection issues there. How about from, let me see, from the Mozambique team, or Mozambique participants, let's say. Do you want to share some of your discussions in your group? I don't know if are people trying to speak? I'm not getting it. How about you, Taylor, from your side?
No, maybe you should.
I don't hear anybody.
Maybe you should call the groups 1 to 10, because they were in groups.
Yes,
Okay.
because the Trinidad and Tobago team did not go into one group. We went into the assigned groups.
Yeah.
Yes,
so
that's okay. That's okay. So, and any one of you, would you like just share us what you discussed in your respective group?
We were in group 6. Let me just connectivity issues. Can you hear me still?
Yes, we can hear you.
I hear you.
So in group 6, we discussed, just a second. We had 8 topics that we raised, challenges. We had occupational health and safety. We also, so do you want me to go through each one right across, or just identify the priority challenges?
The priority challenges, give us like, let's say two priority challenges. Give us like 2 priority challenges.
Okay. So we also have the issue of flaring and venting, and then one that was not related to the actual industry, limited technology, knowledge, expertise in handling the emissions and the leaks. So 3 major ones.
Okay. So the flaring and venting again has come out. Great, thank you. And did you discuss what actions you can take to address some of these challenges?
Yes, we did. Yes, we did. We had a number of, just a second. So we had from Uganda the use of enclosed flares. And then in Trinidad and Tobago, we also had repurposing of the gas in terms of filling of fire extinguishers and the creation of the solid sulfurs from the flares.
Okay.
Okay. I didn't fully catch the last couple things he said. Something about, oh, sorry.
Yeah. Could you just repeat that? It was kind of choppy as well on my side. Use of enclosed flares and safety equipment is what I heard.
Fire extinguishers or something like that.
Yeah. So it's like kind of safety equipment.
And the conversion of sulfur into solids. The sulfur gas into solids.
Yes. Sulfur recovery and conversion into solids. Okay, great. Super. So that was group 6. Now, have we heard from group 1?
Hi, good day. This is group 4 here.
Okay, great. Super. Just come forward. Great.
We spoke on the lack of technology as a priority challenge. I believe this is in one of the countries in South Africa. And well, we didn't explain go into details with regards to the lack of technology. We had for current efforts the partnership agreements.
Okay, partnership agreements with whom?
With government.
Okay.
With government entities, private firms, and the additional steps to be taken, we had innovation, and requests for the need of importance.
Innovation in terms of what?
Innovation in terms of, I believe it was new technology.
Okay. And yeah, you mentioned like lack of technology. Can you just elaborate a little bit on what you discussed there? What did you discuss specifically when you say lack of technology?
Lack of technology in terms of environmental needs.
In terms of what do you mean? If you can just elaborate.
Of equipment.
Can you repeat? I think we lost the first part of what you said.
Lack of technology in terms of environmental equipment for monitoring purposes.
Okay. Yeah, okay. So monitoring, in terms of monitoring and measurements. Okay. Yes. Yeah. Okay, that's interesting. So probably related to like emissions monitoring. So that's definitely something yeah, that's very common across other countries. Great. How about other groups to come forward who hasn't yet provided input? I think group 4, group 6 came forward already. Other groups?
Excuse me, Marisol?
Yes?
Yes, Miguel from group 2.
Great.
Well, in my case, well, I am from South America, no? But
Yes.
my other colleagues was from, it seems to me that Trinidad and Tobago and Nigeria, and also I think Somalia. But in my case, for example, in my country, we have, for example, a lack of training of to respond to spills, no? In general, for not only for operators or the population, but also for the government. And what is doing, well, in my country, people is more aware about this kind of emergencies. So they are trying to get more aware, get more informed. For example, what was doing the government is, for example, to ask for cooperation with international organizations, as well as both public and private, no? Not only, for example, international, but also in my at national level.
Mm-hmm.
Yes. Well, the other was, for example, well, additional steps to be taken are, for example, the promotion of training programs, mainly by main programs to train not only professionals, but also all the population, as well as the legislators or regulators.
Programs. Very good. Thank you.
Yes.
Main programs. Train programs. Good. Thank you. There might be an echo.
Yeah.
other people to mute themselves. Okay, I'll just ask people, others who are not speaking, to mute themselves, please, so we don't have an echo. Okay, great. Okay, other groups or other individuals who want to share what you discussed in your groups?
Can I add something?
Yes.
Yeah, we can include.
So actually, the previous point I just want to elaborate, like, lack of adequate reporting, documenting and reporting of incidents, and transcending that information to the surrounding people or other stakeholders. It may be government, or it may be other, because there is an incident reporting about more technical reports are there, but what its impact are to the surrounding area, they don't know more that part and what can happen. So if that information can be simplified, and so that can be one area of work, and that can be overcome through training, partnerships, and also co-learning among different stakeholders to build coordination, collaboration, so that they can utilize it.
Okay.
Both on-site and off-site.
So this is like really linked to contingency planning as well, right?
Exactly. Yeah. Means in the sense, we have technical stuff on the site, but if it is being transported in certain process, so if there's something happens, then like an accident or something like that, so what should be done? So like SOPs, and so that in a more simplified snippet, information document that can be, and this training is not restricted to one, but everyone in the chain who will be handling this. So that way.
Yes, I think that's a good point.
Yeah. Another is like technological transfer for BAT, because countries are using the ones which are available, but what about something new? So when something new comes up, you need to have the technical training and know-how. So that needs to be also further training, as well as further collaboration with national, international institutions, and also financial support mechanism in doing that. So it requires like local, international, national, as well as regional coordination. So something like that.
Yeah, so I think the idea about need for BAT training, again, let's just remember what we said about, what is best available technology, right? Like we cannot have a one size fits all approach, but we have to then evaluate based on the local and country context, and also based on standards and practice. So, but I think that's a good point. The need for more training and capacity building, I think, has been made. Okay. I think someone from Ghana had.
Can you hear me?
Yes.
Yeah. We can include also for example, the regulatory framework, for example, for CO2, hydrogen, and the methane, because there's this specific those legal framework, and the challenge should be. Can you hear me?
Yes, I can hear you. So we need a strengthened regulatory framework for emission.
Specific, yes, for CO2,
methane,
for nitrogen. So
CO2.
Those there should be the specific regulatory framework for CO2, including CO2. Yes, and the challenge, that is the challenge, and the next step should be involving different etc. for elaborating this legal framework, involving, for example, the government, the ONG, the private, and the
so partnerships.
Yeah, partnership. Yeah.
Involving different stakeholders. Okay. And remember what SM also mentioned, that to reach out to your local national research centers and national universities.
Yes.
Like they can be your key partners in investigating these technical aspects and what can be best available technology in your country context. So
that's true. So another challenge is to get this kind of technology, because as you know that it's expensive. And in our case, we can go for like best available technology in terms of, for example, capture process. This should be the best challenge for us. And we can go for to have this kind of technology, best available technology, but going to the capture process.
Mm-hmm. So this is something that, like, it's a dialogue that you need to have with the operators, right? What is feasible, and what is needed for protecting the environment. So it's like a dialogue. This is what Essam was saying, that it's a dialogue and partnership between the operators and the regulators, and also then other stakeholders, like what the communities, in order to find these solutions. Great. Anyone else? I think, thank you very much, Felix. I think there was somebody from, I thought I saw, was it somebody from Ghana?
Yes, Samuel. Samuel's hand was up.
Well, yeah.
Yes.
Samuel, you want to share?
Initially, yes. I'd want, we were gas processing facility here. They were also having a challenge of having large volumes of isopentane in the after the treatment, and they always approach the regulator, which is the EPA, to give them approval to flare, which we've been doing for some time. So every year they will nominate some volumes, they bring it, then we approve, then they flare. So the actions that they are taking now, because we will give a condition that they have to give us a plan where these flarings will come to an end. So what's happening now is a company has come to build a isopentane stabilization plant where the isopentane will be stabilized, and they will use it. That company has some thermal plants where they will use the isopentane as fuel to power some of their thermal plants. But further actions is a company also has come out to construct a much bigger thermal plants where the isopentane will be used as part of the fuels to be used to generate electricity. Yeah.
Thank you.
On a bigger picture, we have our fields produce a lot of associated gas, and the infrastructure to process the gas is inadequate. So currently, there's flaring management going on the FPSO, but that's a much bigger problem that I think and that will require more time to discuss. Yeah, so maybe next training session, maybe that can be used as a case study.
Can you repeat to me the name of the compound that you're talking about?
Yeah, isopentane. ISO dash pentane.
PEN. Yeah,
pentane.
Like this?
Yeah, pentane.
Yeah, right.
Okay, this is what I think. Well, we can conclude here, and I just wanted to ask.
Pentane is PENTANE.
Yes.
Not
I wanted to ask Essam and Annegret to just comment on this last point about the flaring issue and issues challenges that regulators have with the flaring, and how best to establish a monitoring or management program on this. So maybe Annegret or Esam, would you like to come and just share your thoughts on that?
Yeah, Norway did it since 1971. I guess she has better knowledge about this.
Annegret, are you there?
I'm there. Yeah, okay. Thank you for that. But I think you are on the right track, Ghana, by challenging the operators to present a plan for you, because that is also how we are doing it. So have this plan officially submitted to you with costs and everything, so that you can make a decision. So that's a good one. And the flaring, I think it was positive news from Nigeria with regard to actual plan for phasing out flaring. So good things are going on here. And the infrastructure is important, as Sam also mentioned, that you need to have that. That is also that is the problem very often.
Mm-hmm. Yeah, that's also kind of touches on this issue with when people say lack of technology.
Yeah.
But you have to really invest in the infrastructure to address and manage that. Sam, do you want to add to this discussion?
Yeah, actually, Canada, when they decided to reduce the amount of flaring, what they did, they said to the operators, it's the new act, the new law, and you guys have to stick to it. But as an incentive, you will get some tax credit. And that's why you motivated actually the operators to follow the act. To follow the law.
Mm-hmm. Exactly. So
there are benefits for the operator. The government has to identify the benefits for the operator. What's in it for them? Well, it's the law. They have to stick to it. Fine. That's great. But what else? Okay. Well, you can get some tax credit. Like if you are investing $1 million, then we will distribute all of those $1 million in the next 5 years tax. Let's say something like that. Okay. So the government will benefit, and also the operator will benefit, and the law will stand.
Great. Yeah,
Thank
exactly.
you.
So how to put in incentives, how to put in requirements to ask operators to provide better management and better technology. So so it's good to know that there are countries here in the training room that as part of our training who have these initiatives, and I would encourage those of you who are looking for examples to reach out to your peers from this training and say, hey, I'd like to talk to you more about that. So this is also one of the objectives of having such a training, is to link you up with your fellow peers in other countries. Okay, so this is great. Now, so I think close now this discussion. So thank you very much for sharing, and we will consolidate all of the action plan documents that we have collected through the shared Google Doc that you filled out in your teams. So thank you for that, and really well done in your participation. And you've made it to the very end now of our training. So well done to all of you. I think everyone deserves a clap. All right. Okay. So well done. Thank you, Esam and Annegret, for your presentations.
Thank you, Marisol.
Thank you. So now we will go to closing, all right, and really end our week on a very good note. And I hope you had a chance to really gain some new knowledge that you may not have known, and from your peers and from our presenters. So thank you for that. You can also continue, you can access the Miro boards if there's something you want to add as well. So just in terms of closing, we just have to do a few logistics. So as we said, that in order to receive a course certificate, we would like for you to undertake the final knowledge assessment, which is at individual level. And I'm going to ask Bernice to share the training final knowledge assessment link. So you can already do that now. While you're
go ahead and share. Send it.
While you're
please put it in for me. Okay.
While you're still fresh in terms of the topics. And then I would like for you to also share the training evaluation survey.
Okay.
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 Thank you. So look in the chat. Look for Taylor's name. And he has shared the two links, which is the final knowledge assessment and the training evaluation link. Okay. And if you can complete that today, that would be great. And then we can start providing participants with your course completion certificates. All right. Let me now just conclude. I see that one of our former interns has joined our training today. Hi, Karaman. I see you on the call. So I just want to take this opportunity. Hi. I just want to take this opportunity to thank most especially SM, our course leader, for bringing us through the week, the 3 days. I think we've had very, very good discussions and reflections. So thank you, SM.
Thank you, Marisol, for giving me the chance. Thanks for everybody for listening to me.
It's a real pleasure. And I also want to thank Norwegian Environment Agency and Greta for your participation today. It's always very helpful to have also the perspective of Norwegian sort of regulatory practice. It's always welcome. And last but not least, thank you to Taylor and Bernice, our very able training team, for helping us through and making our training experience very interesting with Kahoots and the Miro board and the breakout rooms. I think we've been, this is the first time we've experimented with such a large training cohort. And I think all of you also deserve a big round of applause. Yay! I think that you definitely deserve, all the participants have made it very easy for us to navigate the training despite our large group. So with that, I wish you a very good weekend ahead. And if you are traveling back to your homes, safe travels. And we will hope to see you in another future event. Speaking of which, just invite you, we have a global webinar series ongoing this year, which focuses on environmental issues related to oil spill preparedness and response. So if you are interested to join, I will, let me see if I can share with you the link. Do you have the link with you, Bernice, for our global webinar series that they can join? The next one will be on May 24, and we will be focusing on environmental sensitivity mapping for oil spill preparedness and response. So I'm going to share my screen so you take a look at it as well. Here, share. Here. So here's also the link to the registration. And then the next one is on May 24. If you missed the February 24 webinar, you can find it on our YouTube channel. Okay. So that's what I also wanted to share with you. And then you will be part of our global network on environment and oil and gas, so you can receive our newsletters, our monthly newsletters. So again, thank you, everyone. I want to wish you all a good rest for the weekend, and thanks again. Bye.
Thank you. Bye. Bye. Bye.
Bye. Thank you.
Thank you. Bye-bye.
Thank you. Bye.
Bye.
Thanks, everybody.
Bye.
Bye. Thank you very much.
Bye. 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 Thank you.
Bye bye, team. Thanks a lot.
Bye bye.
Bye.
Bye. Thank you.